problem number 10. We've got two functions. We have f of x, which is equal to 1 over x plus 3. And then we have g of x, which is equal to 1 over x minus 5. There's two questions that are asked. We need to determine the domain of f of g and then also the domain of g of f. So I'm going to do the first one, the domain of f of g, before I write down the other part. So what this is I've got a number. So this is the composition of functions, right? So first, this says we go through g, because that's the guy on the right, and then we take that value. That's horrible. And we go through f. So to figure out the domain, we need to make sure that whatever we plug into g doesn't make the denominator 0, and also whatever we plug into f doesn't make its denominator 0. So first, let's look. The easy one is, what numbers can't we plug into g? Well, it's pretty easy to see that if I were to plug in 5, there would be a problem there. So 5 can't go in. So one of our restrictions is x can't be equal to 5. Now, the other restriction comes from what number comes out here. Okay, when I plug it into f, I need to make sure that this number that comes out is not equal to negative 3. So I don't want negative 3 getting plugged into f. That doesn't mean that negative 3 is a restriction on our domain, because when negative 3 goes through g, it's not going to come out as negative 3. So what I need to do is I need to see what number, when I plug it into g, so what I'm asking myself is, what number, when I plug it into g, comes out as negative 3. That's the question. So what I'll do to solve that question is I'll take this, and I'll just set it equal to negative 3 and solve, and that'll tell me the x value that I'd have to plug in to get negative 3 out. So if we just do a little bit of algebra here, this is 1 is equal to negative 3 times x minus 5. So this is negative 3x plus 15 is equal to 1. So if I move this guy over to this side, I'll subtract 15 from both sides, so it's negative 14. So x is equal to 14 thirds. So here's what that says. This is, look, if you take 14 over 3 and you plug it into g, watch what happens. So this is going to be 1 over 14 thirds minus 5, which is equal to 1 over 14 thirds minus 15 thirds, which is 1 over negative 1 third, which is 1 times negative 3 over 1, which is negative 3. So the problem with plugging in negative 14 thirds is negative 3 comes out, and then when it tries to go into, I keep doing that, and then when it tries to go into the f function, you're going to have a problem. It's going to blow up. Okay, so our two restrictions are x can't be negative 5, excuse me, x can't be positive 5, and x can't be 14 thirds. So how do I write that in interval notation? I would write it like this. I would say all numbers from negative infinity up to, now 14 divided by 3 is not quite 5, so we'll do 14 thirds first, union 14 thirds to 5, union 5 to infinity. Now let's go ahead and work the other way. So this is the domain of f of g. Now let's get the domain of g of f. So the domain of g of f is, first we look at the restrictions for f, and then we'll look at the restrictions for what we can plug into f so that it doesn't make a problem with g. So the number that I can't plug into f is negative 3. So first, my restrictions on this guy, the first one is x can't be negative 3. The second thing is that I want to make sure that whatever I plug into f doesn't come out as positive 5. Because if I get positive 5 out, I'm going to have an issue when it goes into g. So let's go ahead and work through that. So that's going to be, I want to make sure that f, which is 1 over x plus 3, is not equal to 5. Because if it's equal to 5, that's going to be my restriction. So let's go ahead and solve this. And this will tell me what I can't use. So it looks like negative 14 fifths. So how would I write that? Well, negative 14 fifths is just a little bit more than negative 3. So that'll be negative infinity to negative 3 union negative 3 to negative 14 fifths union negative 14 fifths to infinity.